And welcome, ladies and gentlemen. It's Mr. Callen here with you to help you out with lessons 211 and 212 from Chapter 2. More equations and word problems. Let's go into it. Take a look at your answers, please. Go ahead and hit pause, check your even answers, and come on back when you're ready. And that was assignment 13. Let's go into assignment 14, shall we? Our focus once again for today, I will use algebra to solve one-step equations, and mostly focusing on products and quotients. And yes, ladies and gents, you will see decimals in there. So just remember, please, that sooner or later we will be moving on to 2 and 3 and multi-step equations. It is particularly important that you focus on your algebra steps here. Go ahead and put your name, date. That would not be the date. This, of course, is September. Maybe you're reading this on the 9th. Maybe you're watching this video on the 10th. Put your hour, and then you will notice that I have lessened the number of problems for this assignment. Now, one other thing that I want to point out, usually when we do problems, for instance, page 53, you're going to write the directions, write the problem, write your work, your algebra step, write your solution, and then check it. However, page 55, we're getting into word problems. So ladies and gents, you will not write out the full word problem. Also, when you write the directions, you will notice the directions did not ask you to check. So I'm going to remind you of this before you leave this video. DPWSC, directions problem work solution, check just like normal on page 53. But when you get to page 55, numbers 4 to 7 and 12 to 19, do not write the problem down. Do not write the checking down. Just do the directions and then the work and solution for each problem. All right, go ahead and hit pause, title your paper, and come on back when you're ready. So ladies and gents, today's focus is using the symmetric property of equality to solve equations. Now, what does that mean? Take a look at example 1, please. And I would encourage many of you to write down these examples. 4 and 6/10 is equal to n take away 1 and 2/10. But some students are saying, Mr. Callen, I sure would like that n on the other side. Can we do that? Well, picture an equation which is like a balance, like a scale. To be honest, if that is purely balanced, meaning it's not going one way or the other, imagine spinning that platform in front of you so that one's on the left side, one's on the right side. Does that change the balance? The answer is no. It's not like it magically curves one way or the other. That was a terrible drawing. Don't worry about it. So yes, you may switch n minus 1 and 2/10 to the left side, positive 4/10 to the right side. If I could just point out, though, when you do that, do not upset the balance by accidentally changing the signs. Here's what I mean. I've seen some people purely move it around and say that now n is a negative and now 1 and 2/10 is a positive. No, folks, that would certainly mess with your balance if you change the positive and negative signs. So when this is the case, sure, we want to see what n equals. But listen, we got a pile of money. Mr. Callen's kind of mean, took away $1.20. If we want to know what happened before he took that money away, we need to add that 1 and 2/10 back in. But of course, to keep it fair and balanced, we will do the same to both sides. In other words, add 1 and 2/10, add 1 and 2/10. Nothing upsets the balance. But you will notice 1 and 2/10 and a negative 1 and 2/10 cancels out. Lovely. No need to write in +0, ladies and gents. All that remains on that left side is n equals, and what remains on the right side but 5 and 8/10. Well, maybe. Let's go ahead and recopy the equation. But now we think we know what that missing piece is. So I'm going to take away n and I'm going to substitute in 5 and 8/10. With a little question mark up here. Now you know me, oftentimes I will cover that up with my hand. Let's go ahead and subtract this. 5 and 8/10 minus 1 and 2/10. Take away the tenths place first. Take away the wholes next. And if you do that, you will see, hey, it looks like a true statement to me. Now, once again, if you ever accidentally mess up and you get something like 4 and 3/10 is equal to 4, that's when you can catch yourself and say, whoa, something's wrong, and go back and fix it. Meanwhile, for those of you who would prefer to simply leave the equation as is, we still have a pile of money. We still took away $1.20, so let's add that $1.20 back in, and of course, be fair to both sides. Why does that work? Because minus 1 2/10 plus 1 2/10 make 0. Again, no need to write in that plus 0, but that was our ultimate goal, right? Let's find what that missing piece is. And naturally, when you add that in and then go about with the checking, you will find the same solution. After all, it is a fair balanced scale, whichever side you put the n in minus 1 2/10 and the 4 6/10 on. Pause, rewind if you need, listen to that again, and then we'll go on to another couple of examples. Let's start with example 2, where we have 60 is equal to 1/3 of t. Now, picture this. We don't have the whole, we just have a third. But we sure would like to know what is in that whole. Some of you have great number sense, but listen, I almost don't even care about your answer right here. Do you know how to show your algebra steps? Our goal is to get t by itself. So if you have a third of t, then take 3 of those parts. Why does that work out? Because 3/3 does not make 0, but it does make 1. And I've asked you before, I've told you before, you do not need to write that 1 in. Meanwhile, 3 sets of 60 gives you that whole bit, which is 180. But does that really work? Let's go ahead and rewrite the equation, only instead of some unknown number, we think we know what t is. We think we're going to substitute in and see if it works. Let's go ahead and cover up the 60. 180 divided into 3 parts would be 60. But you already knew that was going to be true. Notice the problem, the work, the algebra step, the solution or our answer, and then the little extra piece for our algebra, and that is checking. One more example, ladies and gents. Hey, we have 40 cents for each, I don't know, gallon of lemonade, whatever it is. But I don't want to know what 40 cents for each gallon is. I just want to know how many gallons. In other words, let's go ahead and split that up into 40-cent increments and do the same on the opposite side. That will keep our equation fair and balanced as long as we divide both sides by the same quantity. Now notice why this works. What is 4/10 of an x divided into 4/10 part? It's 1x. Now let's go ahead and dividing by 4/10. Now before I go off to the side, I'm going to actually move my decimal point over, make that divisor a whole number, but we must be fair. Now you can add as many zeros as you want, but make sure you got that decimal in. Now we say instead of 5 6/10 divided by 4/10, we're doing 56 split into 4 parts, where naturally 4 goes into 5 one time with 1 left over, and 4 goes into 16, a beautiful 4 times. Final solution, x has got to be 14, or does it? Well, there's one way to check before you even turn in your quiz or your test. Take that, but instead of writing 4/10 times a missing piece, we think we know what that missing piece is. We're going to go ahead and write in 14 with a little question mark. Does this work? Now, you know me, I'm going to cover up one side. I'm going to multiply 14 times 4. 14 times 4 is 56. But wait a second. We have one place value here. So one place value here, 5 6/10. And if we remove that, looks like a true statement to me. Once again, folks, for the first few problems, it does not matter to me whether you use the property of equality to switch it around. I showed you example number 1, how to solve it either way, and you'll get the same answer. That missing amount of money must have been $5.80, 5 8/10. So totally up to you whether you turn it around or not. One way or the other, you're going to be able to solve for this equation. So just a reminder, page 53, numbers 20, 24, 29, 30, 33, 34 is all the usual. Write the directions, and then the problem, work, solution, and checking. However, once you get to page 55, You will get into word problems. You do not need to write the problem, and the directions do not say to check it. So simply write the directions and then write down your work. Oh, you know what? I guess I should have been a little more specific though. When you do get to this assignment, instead of writing down all the sentences, you're going to say, okay, 3 more than a number is 27. What's that number got to be? So I guess you will write a problem and then work and then solution, but it doesn't ask you to check. Just don't write all the sentences down, okay? I'm going to write that here and circle it and slash it out. Do not write the word problem out. Just write the original equation and then your work, -3 on both sides, and then your answer. And again, for page 55, you are not asked to check it. All right, ladies and gents, that's all I have for today. Take care, do well. We got a quiz coming up. Whether that quiz will be tomorrow or the next class day, I'm not sure. It depends on what group you're in. But know that that quiz is coming up, so make sure you check your answers, odd answers in the back of the book. Make sure you send some questions on to Mr. Callan, and do not wait for a bad quiz. Let's get those questions answered before a quiz comes around so you can be proud of your efforts and proud of your grade. All right, folks, take care, do well, and let's grow.